In this lesson, we learn about conjugates. Let us take a look at example 1. We use FOIL method to multiply the two binomials. We multiply the first two terms, the outer two terms, the inner two terms, and the last two terms. Now, notice that the terms negative 5 square root of 3 and 5 square root of 3 would cancel out each other. Moreover, 25 and negative 3 can be combined to get 22. Therefore, the product of the two binomials is 22. Observe that there are no radicals in the product because the radicals cancel out each other. The two expressions in this form are conjugates of each other. In example 2, we have this expression. Again, we use FOIL method to multiply the two binomials. We multiply the first two terms, the outer two terms, the inner two terms, and the last two terms. Just like in example 1, notice that the terms negative 8 square root of 11 and 8 square root of 11 would cancel out each other, and we will be left with 64 minus 11, which is 53. The two binomial expressions are also conjugates of each other. What do you notice about the two examples? When we multiply conjugates in this form, where a and b are elements of the set of real numbers, and b is greater than or equal to 0, the radicals would always cancel out each other. We can actually show that this works every time. We use FOIL method to multiply the two binomials. We multiply the first two terms, the outer two terms, the inner two terms, and the last two terms. The terms negative a square root of b and a square root of b cancel out each other. You're just left with a squared minus b. Remember, multiplying conjugates always causes the radicals to cancel out each other. When do we use conjugates? Sometimes we have a radical in the denominator, like in example 1. And we cannot just get rid of the radical. Remember, our goal here is to get the radical out of the denominator. We are not allowed to have radicals in the denominator, and we cannot just remove it by multiplying the expression by square root of 5 all over square root of 5, because we would still be left with a radical in the denominator. The question is, how do we simplify something like this? The answer is we use conjugates. Look at the denominator. We multiply the original expression by 3 minus square root of 5 all over 3 minus square root of 5. Now, notice that 3 minus square root of 5 all over 3 minus square root of 5 is equal to 1 because anything over itself is just equal to 1. We have not changed the value of the original expression, but multiplying 7 all over 3 plus square root of 5 by 3 minus square root of 5 all over 3 minus square root of 5 will change the form of the given expression. Take a look at the solution. We apply dPMA in the numerator and FOIL in the denominator to end up with this expression. Simplifying the denominator, we get this. Simplifying further, we get the final answer. Now, we have rationalized the denominator. Let us take a look at example 2. Again, look at the denominator. We use conjugates and multiply 5 plus square root of 2 all over 5 plus square root of 2, which is essentially just 1. Our solution is similar to the previous example. We apply FOIL method in the numerator and denominator. We simplify the denominator and end up with this final result. Note that we can no longer simplify the numerator. Now, we move on to our last example. Like the previous two examples, we look at the denominator. We use conjugates. We also apply the FOIL method in the numerator and denominator. We simplify the numerator and denominator. Remember, we need to simplify our final answers similar to simplifying fractions. Hence, we end up with this final answer.